In this video, we are going to talk about integration. Now, integration is something finding the area under the graph. Now, we know that any function y is equal to fx will have some shape. So if you plot it on the curve, so let's assume that the shape of this graph is something like this, and I want to find out the area between any two points A and B. Okay, so I want to find out this particular area. To find out this area, what we do is we integrate the function fx dx between A to B, and this integration is going to give me the area of the shaded region, right? So if somebody asks us that what do we mean by integration, it means that finding the area under the graph between the points A and B. This A here is known as the lower limit and B is known as the upper limit. So the area has been found between the lower limit and the upper limit. Now let's try to understand how this integration works, because I have just written the formula integration fx dx, but how is it coming from? I mean, where is it coming from? That is what we are trying to understand from this discussion now. So let me make the figure once again. So I have this axis x and y, and I make this shape, and as I told you that I am interested in finding out the area between 2 points A and B, and I want to find out the area enclosed by this graph with the x-axis. Now the method is not that simple, because we don't have any predefined formula for finding out the area of this kind of shape. If it was a triangle, we could have found out by using half base into height. If it was a rectangle, we could have found out by simply multiplying the length and the width. If it was some other defined shape like circle, we could have used the formula pi r square to get the area. But in this particular case, we are not able to find out the area by the simple method. The reason is very, very simple, that this shape is not having any defined formula. So we devise a method, and the method is something like this. So what we can do is we can take a very, very small strip. This strip is so small, that the width of this strip is assumed to be dx. So this is the width of the strip which I have taken, and the value corresponding to this length is y. Now if I magnify it like this, you can see that this part from here to here, right, this part is almost horizontal. I would not say exactly horizontal, but if the width of the strip is very, very small, negligible small, then we can say that this would be horizontal line. Okay, so if that is the case, then I am very much able to write down the formula for area, which will be length multiplied by breadth or width, because this strip will be nothing but a rectangle. So length into breadth would be the area of this kind of rectangle. In terms of the variable which I have chosen, the length is y and the width is dx. Dx refers to a very, very small change in the value of x. Okay, so this will be the area. Now, starting from A till B, how many such strips can be made? Of course, there can be infinite number of strips. If there were finite number, then I could have written summation of y dx of all such strips. Say there were 100 strips. So I could have straight away written I is equal to 1 till 100. So 100 times the strips area would have been added. But in this particular case, since the differential width of the strip is so small, it is negligible. So I can say that between A and B, there can be infinite number of strips. So there will be infinite number of such strips. And each strip will be nothing but a rectangle, and the area of the rectangle we know it will be y times dx. And of course the value of y will be different at different places. That's why we did not wrote y as a particular number, but y is a function of x. So in that case, if there are infinite number of strips and I keep on adding all those strips together, all the areas of the strips together, I will get the total area of the figure. So that area would be summation y into dx, and this summation will start from the first strip to infinite number of strips. And this case where we have infinite number of strips, this symbol is replaced by integration. So I would say that area would be y times dx, and between which 2 points I am trying to find out the area? Between A and B. That is how this formula of area comes into picture. All right. So in short, we can summarize that integration means finding the area under the given curve between the 2 points which are lower and upper limits. So this is how we can understand the meaning of integration. Now let us try to understand one more thing. Now we have discussed in the previous session that if you have a function fx and I find out the derivative of this function fx, I am going to get a result, right? That result will be another function. It will not be same as fx, but it will be another function. So let's assume that that function is gx. So I take the derivative of fx, I get gx. Now if I integrate gx with respect to x, I will get back fx, right? So this is the relationship between differentiation and integration. You take the derivative of a function, you get another function, you integrate that function, you will get back the function fx with which we started with. Okay, so this is the whole gist of the discussion of integration. Now we will take some examples for this to make things more clear. Before that, I will give you the list of the formulas which we use in physics which are related to integration. Now all these formulas are important. I'm anyways going to give you hardly 3 to 4 formulas, right? I will not give you a big list, that will not be useful for now. So as we know that the derivative of a constant is 0, so this is the first formula of derivative which we did. Then the derivative of x to the power n is n times x to the power n minus 1. right? This thing we have discussed in the video which I shared for derivative. Now if I integrate n times x to the power n minus 1, right, dx, I will get back the same function x to the power n, but there will be a constant added to it. I'll tell you in a while why I'm adding this constant, right? So this is the result of what we discussed here. So what I mean by this is that I have a function x to the power n, I differentiated it, I got another function gx, right? So let's assume that this function is fx and I differentiated this function, I got gx as the answer. Now when I integrate gx, I will get back the same function fx with a constant, of course, and I will let you know why I am adding the constant c, right? So this is what I explained in the previous two steps. So in the same way, so this was my first formula, this is my second formula. For integration, this is my first formula. Now I will write down the modified version of this formula for integration because it doesn't look good, n times x to the power n minus 1, right? So the same formula can also be written as integration of x to the power n dx is x to the power n plus 1 over n plus 1 plus c. So this is my first formula. Similarly, we know that derivative of sine x is cos x. So in integration, we can say that integration of cos x dx would be sine x plus c. Similarly, derivative of cos x is minus sine x. So I can say integration of minus sine x dx will be cos x plus c. Now what I can do here is I can move this negative sign on the other side and I can say that integration of sine x dx is minus cos x plus c, right? So this is the third formula. Alright, I think these many formulas are more than sufficient for now. Let us try to solve a couple of questions based on this and the things will be more clear. Okay, let me give you one more formula which will be useful for our discussion. So that formula here is integration of sine ax dx would be, now see, the difference here is that in the previous step I wrote integration of sine x dx is minus cos x plus c. In this example, or you can say in this formula number 4, instead of x I have ax. So here what I'll do is I'll write down minus cos of whatever the angle is ax, and I am going to divide this by the derivative of the angle ax. And what is the derivative of ax? That is a, right? Of course plus c will come, right? So this is what we need to do. Don't think a lot about how this a was divided and why it came in the denominator. That will be discussed in mathematics, but for now just try to understand how we are applying the formula, right? So let's solve some questions based on this. Say I want to find out the integration of x square dx, right? So as we know, we can use here this modified formula number 1, x to the power n dx is x to the power n plus 1 over n plus 1 plus c. So this would be x to the power 2 plus 1 over 2 plus 1 plus c, which will make it x cube by 3 plus c. So this is my first example. In the same way, if I integrate x to the power 3 dx, this would be x to the power 3 plus 1 over 3 plus 1 plus c, which would be x to the power 4 by 4 plus c. Right? Another example can be, say I want to find out the integration of x square plus 3x plus 2 dx. In this case, what we can do, we can separate these three terms. So I can write the same thing as integration of x square dx plus integration of 3x dx plus integration of 2 dx, right? Now this can be written as x cube by 3 plus 3 times x square by 2 plus, now let's see the third term. In the third term, we only have a constant 2. Derivative of the constant was 0, but integration of constant is not 0. Instead, what we can do is we can write this thing as 2 times integration of 1 dx, and this 1 can also be written as x to the power 0, and now we can apply the formula. So this can be written as x cube by 3 plus 3 times x square by 2 plus 2 times x to the power 0 would be, the integration of x to the power 0 would be x to the power 0 plus 1 over 0 plus 1, which will make it x. And of course, plus c will also come into picture. Right? So these are some of the examples. Let us see some examples of trigonometric function. Say I want to find out the integration of sine 2x dx. This would be minus cos 2x over 2 plus c. As simple as that. Right? So these were some of the examples which will be useful for us. Now here I would like to take another example with the limits also mentioned. The examples which we have taken, we did not put any limits to it. Now what if I put the limits also? Say I want to integrate x square dx between 2 and 5. Okay, now in this case what I'll do, integration of x square would be x cube by 3, right? Of course we have to put c also, plus c, but remember one thing, we put c when the limits are not mentioned. If the limits are mentioned, we don't put c, we put the limits. And how do we put the limits? So what we do is, whatever the result is, we put a square bracket around it and we put the limits here. And now in the next step what we do, we first put the value of x as the upper limit. So upper limit in this case is 5. So we will put the value of 5 in place of x. So 5 cube by 3 minus, then we put the lower limit in place of x. So 2 cube by 3. This gives me 125 by 3 minus 8 by 3. This would be 117 by 3. Right, so we get the answer of integration of x square between 2 to 5 as 117 by 3. So what it means is that x square is a parabola, and the parabola is enclosing an area between the points 2 and 5 with the x-axis, and that area is given by 117 by 3 units. Alright, so this is how we solve the questions based on the limits. Now the integration which is without the limits is known as indefinite integration, and wherever the limits are mentioned, that is known as definite integration. So whenever we have indefinite integration, we put c. If there is no limits mentioned, or you can say whenever there is a question of definite integration where the limits are mentioned, then we don't have to put the value of c. Okay, we don't have to put c, right? So if limits are not mentioned, add c to the result, and if limits are mentioned, then do not add c to the answer. Okay, so this is what we are supposed to remember. Also, let's try to understand why we put a c. Say I want to differentiate x square, right? So the derivative of x square is 2x, right? What it means is that if I try integrating 2x, I will get back the function x square, right? This is what we mean by integration and the relationship of integration with derivatives. Similarly, if I want to find out the derivative of x square plus 5, the answer would still be 2x, because the derivative of x square is 2x, and 5 being a constant, the derivative of 5 would be 0. So the answer is still going to be 2x. Now again, if I try to integrate 2x in this case, I will get x square but not x square plus 5. So to resolve this, what we do is we assume that there was a constant c in the result, right? So even if there is no constant, if the constant c is 0, or if the constant c is present, it will not affect the result of the derivative. So whether you differentiate x square or whether you differentiate x square plus c being anything, it can be 5, it can be 4, it can be -3, -4, anything, the result will only be 2x. That's why we put the constant c here. Okay, so this brings to the end of my discussion about integration. So this is what you are supposed to know about differential calculus, derivatives and integration. This is more than sufficient to understand the concepts which we are going to learn in physics. So I'm sure that this discussion is going to be helpful for all of you. And yeah, so in case you have any doubt, you can connect with me to clear any doubt. Okay, thank you.